What's up, class? It's Mr. Wicklehouse again, and today we are talking about radian measure and angles in the coordinate plane. So we're used to talking about angles in degrees. Well, today we're going to learn how to talk about them with radians instead, which is essentially just it's the same as a degree. It's just a different unit. It's a radian instead of a degree. So we know a few things. The first thing we know is that there are 360 degrees in a circle. Duh. Everybody knows that. Okay. But if we think about that 360 degrees and we want to think about that as pi units or radians, then we know that there are 2 pi radians in a circle. So 360 degrees and 2 pi radians are exactly the same measure. Okay. So what that means then is I can say that 180 degrees is pi radians. Okay. And then what we're doing is we're setting up a proportion. So I know that the degrees over the radians is equal to 180 over pi. This 180 over pi came from the fact that 360 over 2 pi, then we can reduce that, canceling out the 2, and we get 180 over pi. And this proportion is what we're going to use to solve every kind of problem that we have when we need to convert from degrees to radians or from radians to degrees. Okay. So here's a couple of examples. I want to convert, in this case, from degrees to radians, and in this case, from radians, because you can recognize radians because you'll see pi in the measurement, from radians to degrees. So remember, our ratio is degree, or rather our proportion is degree over radians, and that's equal to 180 over pi. Okay, well, our degrees is 135. Our radians, that's what we're trying to find, so we don't know that. And that's equal to 180 over pi. Okay. So now I'm just going to solve for x. So you're going to multiply both sides by pi. And I get 135 pi over x equals 180. Multiply both sides by x. I get 135 pi is equal to 180 x. Divide by 180. I get x is equal to 135 pi over 180. I want to reduce that fraction. I want to reduce this fraction, and this is going to end up reducing to 3 pi over 4, and that's what our conversion is going to be. So this is 3 pi over 4 radians. That measurement there is equal to 135 degrees. I'm going to go out of focus. Oh, it came back. Alright. Alright. So that's how we would convert from degrees to radians. Now let's convert from radians back to degrees. Okay. Doing the same thing using this formula, degree over radians equals 180 over pi. And we're going out of focus again. And then we're going to come back. Not going to come back on that one. Let me get it refocused for you. There we go. So we're going to set this up the same way. We don't know what the radians are this time. So we're doing x over negative 2 pi over 3. And that's going to be equal to 180 over pi. We're going to multiply both sides by negative 2 pi over 3. Okay. You can see here, this is going to cancel out. You see here that there's pi here and pi here, so our pi's go away. So then I've got x is equal to negative 2 times 180 is negative 360 over 3. That means that x is equal to negative 120 degrees. Okay, it's not too bad. Alright, moving on. Here's a little bit of new vocabulary for you. When we're talking about angles in the coordinate plane, okay? Here's our angle. Here's the vertex of our angle. This is called the initial side. This is called the terminal side. Essentially, the initial side is our starting point, or our starting line, or starting ray, however you want to think about it. And we're going to the end of the angle, which is then the terminal side. So, our standard position in the coordinate plane, the initial side is always going to start on the x-axis right here at the start of quadrant 1. So here's our initial side. Then when I draw my angle, my terminal side is just the side where my angle ends in the coordinate plane. So this is just a little example there for you. Okay. Couple other little things. In math, and when we're talking about things in the coordinate plane, especially angles, our angles are kind of opposite of what you would think as far as positive and negative angles go. Positive is always, in mathematics, we go from right around to the left, so it's counterclockwise. It's counterclockwise rotation. That's positive direction. Negative direction is always clockwise. So as we're moving around from this direction, this is going to give us negative angles. So positive is counterclockwise, negative is clockwise. Remember that, it's important. Okay, so a little bit of practice on this. We're going to sketch these two angles. Okay, so let's do negative 385 here. Let me draw a little coordinate plane for us. You don't have to put any tick marks or anything like that on there because we're just talking about the angles. The first thing I notice here is that this is negative. Which, remember, when we have negative, the negative direction is clockwise, so we're going to be moving around in a clockwise rotation. Here is our start, our initial side for our angle, right there. So here's the ray for our initial side. Okay. We're going to go around to negative 385. So in my mind, I know that if I go all the way around, then that's 360. And I know that negative 385 is 25 more than the 360 rotation that I just did, which is going to be right around in here. This is just a sketch, so it doesn't have to be perfect. And there is our terminal side. So I rotated all the way around 360 degrees, negative 360 degrees, because we're going clockwise, and then just a little bit more gave me my negative 385. Okay, let's do this one. Same idea again, draw our axes. Here's my initial side. Always starting that way. I see this is positive, which means I'm going in a counterclockwise direction now. Now we have to use some of our fraction logic here. I know 13 over 18 is smaller than 1. I also know that as far as in radians go, that 180 degrees is equal to 1 pi. 2 pi is 360, 180 is 1 pi. So if I was going all the way to 1 pi, then I would be right here on this line. But I'm going a little bit less than that. 13 pi over 18, again, this is just a sketch, so it doesn't have to be exact. So this guy is going to be right around in here somewhere. And that's my terminal side. So there's my angle right here. 13 pi over 18. Alright? Okay. Now let's talk about coterminal angles. Coterminal angles are angles with different measures but the same terminal side. What does that mean? Coterminal angles are angles that if I have this angle, I'm looking for angles that are going to be the same as this angle, but just 360 degrees more, 360 degrees less. They're just going to overlap each other over and over. So because I'm on a coordinate plane, then these angles, as far as I could go, is 360 degrees, right? 360 degrees. Well, I can continue going in 360 degrees over and over and over again. And those new spots, those are your coterminal angles. So that's why we're thinking to find a coterminal angle, we're adding or subtracting a full circle. So if I have 204 degrees and I want to find a coterminal angle, all I have to do, 204 plus 360, that's 564. So coterminal angle here is 564. I also could have just subtracted 360 and got negative 156. These two angles are coterminal angles. If I wanted to, I could add 360 again to this and get another coterminal angle, or I could have subtracted 360 again and got another coterminal angle, so on and so forth, and so on and so forth. Okay. Let's do another one, except this time in radians. So I've got negative 23 pi over 12. And I'm adding a full circle. So for a full circle in radians, it's 2 pi. Okay. Common denominator, because I'm doing fractions here, 23 pi over 12. 12 is my common denominator. This is going to be 24 pi over 12. Negative 23 pi over 12 plus 24 pi over 12 is just pi over 12. I also could have subtracted 2 pi. In that case, it would have been just negative 24 pi over 12, which would have been negative 47 over 12. Negative 47 pi over 12. Okay. And again, I could just continue to add or subtract 2 pi over and over and over again. Alright. A couple more things and then this video will be over. I know it's kind of lengthy. Okay. We have something here called a reference angle. The reference angle is the angle between the terminal side of your angle and the closest side of the x-axis, always acute and positive. So in other words, I've got my axis here, I've got an angle, here's my terminal side. The reference angle is this angle right here. It's the angle that is formed from the terminal side and the x-axis. Okay? So, let's do a couple examples. So I want to find the reference angle for 585 degrees. If the angle is not between 0 and 360, then we need to find a coterminal angle that is between 0 and 360. Okay? So what we're going to do there is we're going to take the 585. Since it's bigger than 360, I'm going to subtract 360 degrees, and I get 225. Okay. So I need to think about where this angle is so that I can locate it so I can find my terminal side. Okay, so here's this. Here's our initial side. And I'm going to 225. So I'm going around. There's 180. Going a little bit further, this here would be 270, so that means this guy is right around in here somewhere in there. So my reference angle is going to be this angle right here between this terminal side and the x-axis here. I know that this measure here is 180. So to find this reference angle, I take 225 and I subtract 180 degrees and I get 45 degrees, and 45 degrees is my reference angle. Okay. Let's do one doing radians. So find the reference angle of 12 pi over 7. And it's in quadrant 4. How do I know that? Well, I know that 2 pi would be 360 degrees, which means that 14 pi over 7, that's going to be equal to 2 pi, so that's not quite here. Okay, so here's my initial side. I'm going all the way around to over here. Going to be right around in there somewhere. So my reference angle is going to be this angle right here. So what I can do then is I take 2 pi, because it's closest to this x-axis, and that's 2 pi, and subtract 12 pi over 7, which is going to give me 2 pi over 7. That's all there is to it. That's all I'm going to torture you with today. I will see you guys in class.